This is AP Physics Electrostatics video number 5. Starting off the second Cyber Week, we'll be using this as we close out our unit on electrostatics. So anyway, what I have today, you can see the balloon is attached again to its regular string. But then also what I've got here is I've got a wire that's headed up towards a light fixture that's attached to the ceiling, and it's attached via metal alligator clips through a conducting wire up to another alligator clip, which goes up to the light fixture at the ceiling. So you can see all that right there. All right, so what I'm going to do is I'm going to charge up the rod. I'm going to hold it next to it, and you're going to see probably something that I don't know, maybe surprising, maybe not. First off is what's going to happen if I charge the rod up while the balloon is attached via conducting wires up to a metal thing that's attached to a metal thing that's attached to the ceiling. Now the theme here is grounding. Okay, when something's grounded, that means it's electrically conductive, conducting all the way to a large ground, so to speak. Ground can be a lot of different things, but the idea is that the ground is either a source or a sink for electrons from something that's charged. So, all right, so guess first what's going to happen if I charge up the rod, put it next to it. Probably no big surprise there. Okay, it's attracted, still attracted. Okay, I'm going to do it again. Still attracted. Again, still attracted. Again, still attracted. Again, still attracted. Well, you might remember by now, with about that many chargings in the previous video, if I kept on charging one of the balloons, eventually it started to become repelled from the rod, okay? And here, it always seems to like it, right? So first question for you is, what's going on? You know, why is the balloon continually attracted to the rod? So that's the first question to ponder just for a few seconds here. Still likes it. Still likes it. And keep charging this thing up, and it still likes it. Okay. So the question is, what's going on? So if you guessed what the ground is doing, right? If the rod is negatively charged, what the ground is doing is it's taking extra electrons away from the system and taking them to the ground. So it's a sink for electrons in this case. So when I put the negatively charged rod on here, the thing's attracted to it, right? Because the rod is inducing the opposite charge on the balloon at that point, making that side positive. That means the electrons want to run away because they don't like that negatively charged rod. So where do they run to? Well, in this case, they've got a path all the way to a very large source for empty space for them to spread out, so they don't have to be close to their like charges. So they're trying to maximize their social distancing. Ha ha, I know, it's not funny, is it? Okay, but the electrons don't like being near each other, so what they do is they run away as far as they can get, and so they go to the ground. Okay, so last question for this video is, okay, I've been continually charging this thing up, charging it up, just never seems to want to quit here. Question is, I'll do this maybe one more time. Okay, and then we'll let it settle down for a second. Make sure it's in view so you can see it. All right, and I'm gonna put my hand near it right now. Okay, after all these times of charging it, you know, what's gonna happen if I put my hand near it? All right, you got three choices on this. A, it's gonna do nothing. B, it's gonna be attracted. And C, it's gonna be attracted so much that there's gonna be a pop and a spark. So, make your guess. Think about it for a second, and then I'll try it. Okay, ready, set, I'll put my hand right near where Mickey's face is over here. Ready, and get real close. And the answer was nothing. If you guessed nothing, you went all in on nothing, good job for you. Again, the idea is that when you ground something, and the excess charge that's on it goes directly to the ground, which is this big wide open space, so the electrons can maximize their spacing from each other, and that's what they're doing in this case. So that's why electrical appliances are grounded. That's why you have a third prong on some outlets, so that you don't build up any excess charge on an appliance, and so you're allowed to take any excess charge that might build up directly to the ground, and therefore eliminate a shock hazard for people. Okay, that's it for AP video number 5, and we'll be meeting with you live this week via Google Meet and invitation. Bye-bye.